So we're talking about percentage error in standard form. And one thing you need to understand is what exactly is error. Okay, error is the difference between an estimated or approximated value and the exact value. Okay, and that's what this formula is here. Error is equal to A sub B minus, B sub A minus B sub E, where A represents the approximated value and E represents the exact value. And that formula is used to find percentage error, which you take your error, the approximate minus the exact, you divide it by the exact, and then what do these bars mean? Take the absolute value of that decimal, that fraction, and then multiply by 100 to get the percentage error. Okay? And then that's how you determine exactly know how far from the exact value is was your estimate. Okay? That's how we determine percentage error. Let's take a look at an example using percentage error. A couple of examples. Okay? We'll work through this one together. Alright? So you don't have to worry about writing it down. You'll write down the next one. Okay, which is a little bit longer. So the size of angle M is 125.7 degrees. Solomon measures M, the protractor, as 126 degrees. Find the percentage error he made in measuring angle M. Okay? So we have to find the percentage error, which is the formula, the absolute value of the approximate minus the exact, divided by the exact, times 100. Now, which one of these numbers is the approximated value? 126. So then that means that this one here is the exact. Then we need to make sure you can figure out which one is which, because then you just go and plug it in. So the absolute value of 126 minus 125.7 divided by 120.7 times 100. Okay, simple as that. Use the formula. Now, real quick, what does absolute value do to a number? Makes it positive if it's a negative. What if it's already positive? Stays positive. So when you go to type this into your calculator, if you know that, you won't have to worry about trying to figure out where is absolute value in your calculator to do that. Okay? You just need to know that whatever this decimal is, if you multiply by 100, if it's negative, it shouldn't be that. It should be positive. Okay? Percentage error is always positive. Always positive. However, teach for a moment here. Let's see where absolute value is in the calculator. Okay? So, absolute value is located. Press math. Remember, math is what we press when we wanted to convert a decimal into a fraction. Okay? Go over to number, the NUM. And option 1 is ABS. That stands for absolute value. You click enter. Now, if your calculator is like mine, actually will show the absolute value bars. But if yours isn't like mine and it just shows you ABS with parentheses, that's fine. Okay? It's fine. You still would type it in, okay? Now I want to do 126 minus 125.7. I'm putting that in parentheses. Why am I putting that in parentheses? So it does that. It actually subtracts them because what comes after this? What do I have to do after this? I have to divide. And I want to make sure the calculator knows that I am dividing whatever that difference is from the actual exact value. And if yours has the parenthesis, with the ABS with the parenthesis, you do want to include, basically what I typed in here is exactly what you want to type in. Okay? And once you get to this point, you just want to close off the parenthesis again. So you should have this set of parentheses and then the one around the ABS. Times it by 100. So go out of that, times by 100. And there's your percentage error. How do I round this? 3, 6, fix. So what's my final answer? 0.239. that is a percent. So that will be your answer. Okay? All right. So again, just for video's sake, if you get a calculator that just has the ABS and it pops up, you just insert in another parenthesis, do the math out. Close that out, and then times 100. Okay? That's what yours should look like. Questions on this? Okay. I want you to give this example here. There was an example 1, but I went ahead, for time's sake. I want you guys to do example 2. This is the one I want you to add to your notes. Okay? I want you guys to give it a try. It is kind of some throwback questions in there as well, but I want to see if you guys can work this out. Okay? All right, so the area of a circular garden is 89 meters squared. We have to find the radius of the garden correct in 3 decimal places. So, how do I do that? Summer, how do you start? And then, very good. Awesome. So we have to find the radius of the garden. So you basically need the formula for the area of a circle. You set that equal to 89, divide by pi, and then take the square root. And yes, this is some decimal that you could have gotten before you took the square root, because I'm not trying to hear all the numbers, I just wrote it this way. So we go into our calculator, and we do this out, and it says rounding to 3 decimal places. Give me 3 significant figures when you first said it. So what's it? 5.3, 2, 3. Because it said 3 decimal places, not 3 significant figures. So you gotta be careful. You gotta be careful. Okay? One thing you also have to realize, one thing I haven't said yet, is that say you do make a rounding error, they only penalize you 1 time for the entire thing. Okay? So, you can just mess up when you're rounding consistently throughout. They're only going to penalize you 1 time for that round. Now, maybe throw a couple other numbers off, but be careful about that. Now you have to find the perimeter of the garden. Now, perimeter of a circle is called what, Shelby? It's called circumference. And what is that formula? Pi r2. Yeah, so it is pi times diameter, or pi r2 to pi r. And so the one thing, guys, that I want to make sure that you remember from what I said on Thursday is if you have to use a part from, if you have to use an answer from a previous section, like previous part, don't use the rounded answer. Use the more exact one. Okay? Mind you, you rounded here to get the radius, which means that you're going to be putting a rounded answer in to only have to round again. And it looks like we have to use our answer to part B, to part C, so you're continuously rounding further and further away from the more exact answer. Okay? So when you went to your calculator and you did the square root of 89 divided by pi, maybe not like this, but you got that. Now we just have to multiply this by 2 and by pi. So just do times 2, because it takes the previous answer, multiplies it by 2, and then multiply it by pi. Okay? Just go straight into it. And hopefully everybody got this. And how are we rounding? 3 6 fifths. Doesn't tell us how to round, does it? No. Another thing that you guys need to be aware of. Not so much for me, actually for me, because I would like to know. But more for the grader who's going to be grading your paper in your senior year. If you're planning to use the longer answer, not the rounded one, and you're trying to show your work, basically just go in, write the number, and then just put dot, dot, dot. That lets the grader know that you're using the full decimal, whatever you got in your calculator, versus the rounded one. Does that make sense? So then that way they can at least try to award you some method points if, say, your answer's not right. Okay? So, what was the answer? 33.4? Yeah? Yeah. There we go. Now, Jose estimates the perimeter of the garden is 30 meters. You're going to use our answer to part B to find the percentage error made by Jose, corrected 2 significant figures. Percentage error 33.4. Okay, that's fine. And I know it does say use the answer to part B, but I don't know. I guess I'm such a stickler for like, I have to use a previous answer. I want to be as exact as possible. Just continue to use the full decimal. It's already there, right? It's already in your calculator. But I don't think if you use the rounded, you're going to be that far off from the final answer for two significant figures. Okay? What did you guys get when you did that? Did you use the rounded? Yeah. Okay, so then it is going to make a difference. And it knows that far. Okay? So let's do the checkers real quick. See.
30 minus 33.4.
Okay, I know it's the absolute value of that, so I know it's going to be positive. Oh, careful. Because we're rounding two significant figures, that one means you keep the same. You don't round up. So it's actually 10. Which makes sense because 33.4 and 30 are pretty far from each other. Okay. Questions? Good? Awesome. Yes. Standard form is just one way to write super large numbers or super small numbers, okay? Standard form is written in the form of a times 10 to the k, where a is in between 1 and 10, and k is an integer. You guys have seen that notation. What was it called back in Algebra 1? A times 10 to the k. Say again? Scientific notation. When they ask you to write something in standard form, they're asking you to write it in scientific notation. Okay? And remember, scientific notation was a way that we represent really, really large numbers or really, really small numbers. Okay? In a small, shorter, more condensed way. And these were the stipulations behind what A had to be and also what K had to be. Okay? So we're just going to review scientific notation back from your Algebra 1 days. Okay? With these two examples here. And then we'll look at one more on like the IV scale of things. Okay? Alright, so to write these in standard form, aka scientific notation, remember, A has to be in between 1 and 10, which means this super big number here is not going to apply. We take the decimal point, which is located where for A? At the end, right? And then we have to move it so that way this number turns into a number that's in between 1 and 10. So we got to move it back. That's 1, 2, 3, 4, 5, 6, 7, 8 places. Right? Turning this number into 2.57. A number that's in between 1 and 10. So that's A. Then it's going to be times 10 to the what power? 10 to the 8. However many spaces you move back, that is going to be the number in the exponent. Now remember, a positive exponent makes the number bigger, a negative exponent makes the number smaller. Okay? And also you can always check by going into your calculator and doing 2.57 times 10 to the 8, and it'll give you this, hopefully it'll give you this number. Depending if the calculator might not be big enough to hold all the zeros. I think it is. Same thing here, here's the decimal. We have to move it 4 to the right to make A a number be between 1 and 10. So 4.3 times 10 to the what? Negative 4. Now, if you were ever curious what that E meant in your calculator, that's what it means, okay? That E represents a base of 10 with an exponent of whatever. So if, say you wanted to check this, like, okay, well, I just wanted to check this to be sure. Well, 4.3 times 10 to the negative 4 is going to pop up like this. That E means scientific notation, okay? So that means you just got to move the decimal place to 4 spots to the left, okay? And then you have the same decimal. Yes?
Are we allowed to use E instead of 10?
You you want to make sure you use the particular notation because it's going to ask you to write it in that form. So you definitely want to make sure you write it in that form. That's a good question. Okay? So there you go. Standard form, aka scientific notation. Alright? Now let's look at one, an IB type of a problem. Okay? Okay. I'm like, oh, like, hey. Okay.
They got them weird words in there.
Alright, let's do this one. Okay? And because it incorporates a little bit of what we just talked about, and then standard form, okay? So I'll give you guys a second to write this down. Alright, so we have to write down the weight in the form of A times 10 to the K, where A is in between 1 and 10, 1 included 10 not, and K, symbol. See, what does this mean right over here? What does this mean?
Easy.
Not easy. I mean, it is
What?
integer. K has to be an integer. Okay, don't forget about the symbols from day one. Okay, they might, instead of saying K is an integer, they might use the symbol instead, so you gotta be able to recognize. Okay, so we have to write down this weight in that form. Okay, so 2690, where's the decimal? At the end, how many times do I have to move it over? 3, so that is a number less than 10 but bigger than 1. And it's going to be times 10 to the what? 3. Very good. Now it says Nelson estimates that the measure of the container is 2.7 times 10 to the third. Write this mass down in full. So that means this mass, the one they just said, what is that number in full? 2,700? Very good, because you're taking this decimal and you're moving over to the right. 1, 2, 3. So you got to fill in zeros for that spot there. So there's your answer for B. I. Now B double I says find the percentage error. We just talked about this. Percentage error. What's the approximate? 2,700. What's the exact? 2690. What am I dividing by? 2690, and then what am I doing to this? Times it by 100. That's how you're going to find the percentage error made by Nelson in his estimation. Okay? So you type that in. Remember, you really don't have to worry about the absolute value because you already know this should be a positive number anyway. And what do you get? 372. Okay, let's take a look. Divide this by 2690 times by 100. 2.372. Okay? Questions there? On standard form or the other way around. None? You guys think you got it? Okay. You guys doing this one? What was the value of X? Give a full calculator display. What you get? Huh?
1 6 is
Was there a 1 in there?
yeah, it is
1, 6. How many sixes?
8.
And then a 7? Okay. So you write on the full calculator display. And it says, write your answer to part A, correct the 3 significant figures. What would it be correct the 3 significant figures? 0.167. Then it says, take your answer to part B and put it in the form of A times 10 to the K, where all the stipulation is applied. either.